Hi everyone, hi dear students. Today this video is in continuation with previous video of module 5 part 1. Now this is module 5 part 2. So in this we are going to discuss k-means clustering in detail. In the previous video also I have discussed a bit little bit regarding the k-means clustering. So we'll move further. So already this is covered. K-means clustering is a partitional clustering approach. So here each cluster is associated with a centroid, or we call it as a center point. So each point is assigned to the cluster with the closest centroid. So the number of clusters, that how many clusters you want to have, that k must be specified. So what is the procedure here? You need to select the k points as initial centroids, and this you should go on repeating. So then form k cluster by assigning all the points to the closest to the centroid. So initially take one centroid point and select or assign all the points nearer to that point, assign into the one cluster. So this we should go on repeating until we get a k number of clusters. So for example, if you want to have 5 clusters, so all your clusters should be equal to, so if k equal to 5, then I should form totally k clusters, and all these k clusters should have points or the objects which have similar properties, and that should not have properties of the neighboring clusters. Okay, so this thing also we have covered. So complexity of the clustering algorithm is O of n into k into I into d, where n is the number of the points and k is the number of clusters and I is the number of iterations, that is how many number of times you are going to repeat the clustering algorithm, and d is equal to the number of attributes. So now if I want to evaluate, so how properly a k-means clustering is performing. So evaluating a k-means clustering algorithm, so if you want to evaluate the performance of the k-means clustering algorithm, we use a measure called as sum of squared error, that is called as SSE. So each point, the error is the distance to the nearest cluster. So here we are going to compute the distance between the 2 points. Okay, or distance between one point of one cluster with respect to the other cluster. So here, if the distance is more, then the clusters are very much far away, and if the distance is less, then one point belongs to the more number of clusters. So we need to form clusters in such a way that all the clusters, all the objects in one cluster should belong to only one cluster, and that should not be a part of the other cluster. So what is the sum squared error? SSE is equal to summation I equal to k. So all the k iterations, so how number of clusters I want to form? K is nothing but how many number of clusters I want to form. Okay, so then I equal to 1, we start with 1, then we'll move up to k, then summation x of x belongs to c of I, distance square into m of I comma x. So what is this x? X is a data point in a cluster C of I. And what is m of I? M of I is the representative point of the cluster C of I. Okay, so m of I is nothing but the mean, or nothing but the center of the cluster. So when given 2 clusters, we choose the one with the smallest error. So take 2 clusters, take 1 point. So take 1 point, match with the 2 clusters. So to which cluster it gives the smallest error, to that cluster it belongs. So if it belongs to cluster number 1, if the error is 0.01, and when you take cluster 2, the error is 1, then it belongs to cluster number 1. So that is how we evaluate the performance of a k-means clustering algorithm. Next, this also I have discussed in the previous class. This is just a repetition. So if I want to reduce the sum squared error, I need to increase the value of the k, that is the number of the cluster. Okay, so what is this p? P is equals nothing but the probability. If the clusters are in small size, then n, then p is equal to probability that how many number of clusters I can form properly. Okay, so number of ways to select one centroid from each cluster. What is this probability? Probability p is nothing but the number of centroids, probability of forming number of centroids. So how many number of centroids will come into picture? So that is come into picture only when we run the algorithm. So P is equal to number of ways to select one centroid from each cluster divided by number of ways to select k centroids. That is nothing but k factorial divided by k raised to k. For example, if you take k equal to 10, then what is the probability? 10 factorial by 1010, that is 0.0036. Okay, so sometimes what happens, the initial centroids will adjust themselves in a right way, or sometimes they do not. Okay, so now coming to the next point, k-means. What are the additional issues associated with the k-means clustering algorithm? So handling the empty cluster is one of the basic issue that comes with the k-means clustering algorithm. So basic k-means algorithm can yield empty clusters. So when we are running a k-means clustering algorithm, sometimes what happens, a cluster algorithm will lead into a generation of the empty clusters. So now a cluster is empty, which is not having any objects or any points. Then what is the meaning of generating such type of the cluster? This is one issue which on which we need to concentrate whenever we are applying the k-means clustering algorithm. So the k-means clustering algorithm should not generate any empty clusters. We need to take care of that. So several strategies to address this. So when a k-means algorithm yields an empty cluster, what we have to do? So choose the point that contributes most to the SSE. So now whenever you are selling, so to make sure that your k-means clustering algorithm should not yield, to make sure that your k-means clustering algorithm should not yield empty clusters, what we need to do is, I need to select the point, or I need to take into measure of the sum squared error. Choose the point that contribute most to the sum squared error. Choose the point from the cluster with the highest SSE. This is second method, and if there are several empty clusters, the above can be repeated several number of times. So the above two steps, choose the point that contribute most to the sum squared error and choose the point from the cluster with highest SSE. Then go on repeating this until there are no empty clusters remaining. So if empty clusters are coming again and again, then you need to repeat it several number of times so that all the clusters are having good number of points which are having similar property one to one another, and they are not having, and any other cluster should not be an empty. So now another point, that is updating centers incrementally. So in the basic k-means algorithm, so centroids are updated after all the points are assigned to a centroid. So now what happens, initially what we do, we take one centroid point, we form a cluster. Then in second iteration again, what happens, the centroid goes on changing. Because when you go on increasing, so when you go on changing the centroid points, what happens, the distance goes on varying in the distance, that is Euclidean distance goes on varying, which results in more number of points coming into the one cluster. So in the basic k-means algorithm, so centroid points are updated after all the points are assigned to a centroid. So an alternative is to update centroid after each assignment. So that is we call as an incremental approach. So update the centroids after. So once you do an assignment, so that is then update the centroid after each assignment. So most assignment updates 0 or 2 centroids. So maximum number of, you can have 2 number of centroid updates you can have, but if you go on incrementing, so if you go on increasing the centroids incrementally, so this is a more expensive approach. So and it also introduces an order dependency. Okay, so but the advantage of this thing is that you will never get an empty cluster. So you can use weights to change the impact. So you can this is another way how we can update the centers of a cluster. Next, what we need to do. So before applying the k-means clustering algorithm, what we need to do, we need to perform two operations that we called as pre-processing and post-processing. So what we do in a pre-processing, normalize the data and eliminate the outliers. So here, before I apply a k-means clustering algorithm, the first thing what I need to do is, I need to normalize the data. Then, second one, eliminate the outliers, eliminate the noise. Outliers are nothing but the points which are not a part of your cluster, or the points which are a part of the noise. Those noise points or outliers has to be removed. So this is what we need to do before processing the k-means algorithm, before applying the k-means algorithm. So next coming to the post processing, when you normalize the data, so when you eliminate the outliers, Then the post processing, what we need to do? Eliminate small cluster that may represent outliers. Now, even though when you have removed outliers, small points that are a part of the noise, those you have eliminated. But still, some noise points will remain as a cluster. So, eliminate those small cluster points that may represent an outlier. So, that does not belong to any cluster, that does not have properties of the any cluster. Those small cluster you need to eliminate. Okay, so eliminate small cluster that may represent an outlier. Then split loose clusters, that is cluster with relatively high sum squared error. Okay, so now what we do, you need to split the clusters. So if you take one cluster, so if all the points in that cluster are showing the highest sum squared error, then what we need to do is we need to divide that cluster into two clusters. So that is split, that is lose nothing but dividing a cluster, splitting the cluster into two clusters so that sum squared error is reduced. Then merge two clusters that are close and that have relatively low SSE. So now there are 2 points over here. So if the sum squared error is more, then you are going to divide a cluster, you are going to split the cluster into two parts, or if the two clusters are very close to one another, or if the two clusters are having relatively low sum squared error, then what you need to do is you need to merge those two clusters. Okay, so and you can use these steps during the clustering process. During clustering process you can use these things, that is splitting of the clusters or merging of the clusters based on the value of the sum squared error. Now coming to the strengths and weaknesses of a k-means algorithm, that is this is called as limitations. So strength and weaknesses, k-means is a simple and can be used for a wide variety of data types. So k-means is a very simple algorithm. K-means clustering is a very simple approach. It can be applied to a very different variety of the data you can apply. It is also quite efficient even though multiple runs are often performed. So even though as you know, k-means clustering is a very simple approach. This is one part. Second one, so it is a very efficient algorithm, and even though, but the thing is that you need to run the clustering algorithms or clustable in multiple number of iterations. So then k-means is not suitable for all the type of data. K-means is suitable for wide variety of data, but it is not suitable for some set of the data that cannot, where we cannot apply the k-means algorithm. So k-means is not suitable for all the type of data. Then k-means has problem when clusters are differing. Okay, so when differing with respect to what? So when k-means clustering algorithm is very difficult to apply when the size of the clusters are different. When two clusters if you take, if the two cluster sizes are very different, then it is very difficult to apply the k-means algorithm. So when the density varies, variation in density of the points, so if the number of points in a cluster or the variations in the densities is there, then k-means algorithm is also very difficult to apply. Then when you have non-globular shapes, when you have non-globular shapes of the clusters, then also the k-means algorithm has problem. So k-means algorithm has problem when you apply when the clusters of the sizes are different or the density is not regular and non-globular shapes are present. So even and k-means has problem with the data contains outliers. So if you present a data if you are applying a k-means algorithm to an cluster to an data that contains an outliers nothing but the noise, in that case also k-means clustering is also having a problem. So next, coming to the one more point, the bisecting k-means. So bisecting k-means algorithm is a straightforward extension of the basic k-means algorithm. So now k-means algorithm and bisecting k-means algorithm. So bisecting k-means algorithm is again a variation of the k-means algorithm. It is a straightforward approach. Okay, so that is based on a simple idea. What is that idea? Obtain k cluster. So initially what we do, that we do in k-means clustering also. In k-means clustering also what we do, we obtain k clusters. Then split the set of all the points into two clusters. So now what do you do? Obtain K means cluster, obtain K cluster, then what you need to do is split the set of all points into two clusters. Then select one of these two clusters to split, and so on until K clusters have been produced. So take one cluster, go on dividing it. Okay, so initially obtain K clusters, split the set of all the points into clusters, select one of these clusters to split, and then so on until you have clusters until K clusters have been produced. So what is this algorithm, bisecting K means algorithm? It consists of. So what we initially need to do is initialize the list of the clusters to contain the cluster consisting of the all points. So initially we are going to initialize the list of the clusters and all the points. So this I am going to repeat. So next step, second step, we are going to continuously repeat this until all the points come into the cluster. Then remove a cluster from the list of the cluster. Perform several trial bisection of the chosen clusters. So out of K cluster, take one cluster from the list. Then what you need to do is perform several trials, bisections of the chosen cluster. Okay, so for I equal to 1, 2, the number of trials you want to do. So if you want to do 10 trials, then for I equal to 1 to 10. Okay, so for I equal to 1, I equal to 2, I equal to 3, up to 10 we need to do until we get a proper number of clusters. Then bisect the selected clusters using K-means algorithm. Then select two clusters from the bisection with the lowest total SSC. Now I told you need to select two clusters. So when we select two clusters, what we need to do is we need to two clusters from the bisection with the lowest sum squared error. Okay, then add these two clusters to the list of the clusters. Then until the list of the cluster contains K clusters. Okay, so then there are a number of different ways to choose which clusters to split. Okay, so now which cluster I need to take? So when you have K number of the clusters available, so which cluster I need to take? There are a number of different ways to choose which clusters to which clusters I need to select. So choose a cluster, choose the largest cluster at each step. So take. So whenever you are performing bisecting the things, whenever you are bisecting the a cluster, now you need to select a cluster with the largest size. Choose one with the largest SSC. One approach is choose a cluster that is large. Choose a cluster which is having largest sum square error. Choose a criteria based on both size and SSC. Okay, so either you can use size based, that is whether it is a small or large. So if you select a cluster based on its variation, that is if you select a large cluster, then it will be based on the size. Then if you select a cluster for bisection based on the SSC, then it will be an SSC. So based on the criteria, either you use a size or a sum square error, different choices will result in different clusters. So let us take K-means clustering algorithm. So one example we will take, use the K-means algorithm and Euclidean distance. So here we need to apply the K-means algorithm, and we are being asked to use the Euclidean distance to the cluster, the following 8 examples into 3 clusters. So now there are 8 attributes there. Okay, so use the K-means algorithm and Euclidean distance to cluster the following 8 examples into 3 clusters. So we have 8 examples, A1 to A8, and I need to group all these things into only 3 clusters. So I need to apply K-means algorithm, I need to apply Euclidean distance, and then I need to group all these clusters into only one cluster. So now what this table shows. So A1 to A1, so this table shows you the Euclidean distance. A1 to A1 is 0, A1 to 8 is root of 25, A1 to A3 is root of 36, that is Euclidean distance. A1 to A4 is root 13, and A1 to A5 is root 50, and A1 to A6 is root 52, and A1 to A7 is root 65, and A1 to A8 is root 5. Okay, so now what I need to do is I need to do? I need to take all these 8 different points into only 3 clusters. Suppose the initial seed points, the center of the cluster are, so let us take A1, A4 and A7 are the initial centers of the clusters. So initially, so out of these 8, A1 to A8, we will select A1, A4 and A7, these 3 points as the center of the cluster. Then we are going to run the K-means algorithm for one epoch only, for one iteration only. At the end of each epoch, what we'll get a new cluster, centers of the new cluster. Then I need to draw a 10 by 10 space with all the points that show which cluster is present at what location. Okay, let us take with this. So D of AB denotes the Euclidean distance between A and B. So what denotes the Euclidean distance between A and B? It is obtained. So it is obtained directly from the distance matrix, or DAB, Euclidean distance between D and AB. A and B is equal to D of AB is equal to square root of x of B minus x of A square plus y of B minus y of A square. Value of B on x direction, value of A on y axis, value of B on y axis, and value of A on y axis. So what are the initial points given here? Seed 1 is A1, seed 2 is A4, and seed 3 is A7. What are the values of seed A1? 2, 10. What are the values of seed 2 A4? 5, 8. What are the values of seed A7? 1, 2. Let us start the first iteration. So A1. So A1 is, what is the seed 1? Seed 1 is A1. A1 to A1, what is the distance? What is the distance from A1 to A1? It is 0. So A1 to A1 is 0. So as A1 is a seed, okay, then A1 to seed 2. A1 to seed 2. A1 to seed 2. What is the seed 2? Seed 2 is A4, 13. So A1 to A4 is 13, which is greater than 0. Then A1 to seed 3. What is seed 3? A7. What is the A1 to A7? What is the value? Distance value, Euclidean distance value? 65, which is greater than 0. So A1 belongs to cluster number 1. Okay, so A1 does not belong to cluster number 2 and A1 does not belong to cluster number 3 because I am choosing the smallest value. Then you take A2. A2 seed 1 is A1, seed 2 is A4 and seed 3 is A7. A2 to A7, A2 to A1, what is the value? A2 to A1 is root of 25, then A2 to A4 is root of 18, then A2 to A7 is root of 10. Okay, so then A2 to A1 is root of 25, that is value is 5, then A2 to A4, C2 is A4, that is root of 18, 4.24, then A2 to A3, A2 to A7, root of 10, that is 3.16. What is the smallest value? 3.16. So 3.16. So then A2 belongs to cluster number 3. A2 belongs to cluster number 3. Then coming to A3, A1 to A3, what is the value? Root of 36. A3 to A1, root of 36, 6. A3 to A4, root of 25, 5. A3 to A7, root of 56, 7.2. What is the smallest value? 5. What is second? Seed 2. Seed 2 is second cluster. So here seed 3 is third cluster. So this belongs to third cluster. Here smallest value is seed 1. So it is first cluster. So here why it belongs to third cluster? Because smallest value is with respect to seed 3. So here smallest value is with respect to seed 4. That is second cluster. Similarly for A4, root 13, 0, 52. So A4 belongs to second cluster. Similarly, A5 belongs to cluster number 2, A6 belongs to cluster number 2, then A7 also belongs to cluster, A7 belongs to cluster number 3, and A8 belongs to cluster number 2. Then finally, new cluster. So cluster number 1. So cluster 1 is having only A1. So cluster 1 is having only A1. So cluster 1 is having only A1. So cluster 2. So cluster 2, what are the points in cluster 2? A3, A4, then A5, A6 and A8. A3, A4, A5, A6 and A8, that these all points belongs to cluster number A2. Then cluster number 3, which points? A7 here, then A2, that belongs to cluster number 3. So A2 and A7 belongs to cluster number 3. So then, center of the new cluster. So what is the center of the new cluster now? So what is the center of the new cluster? C1. What is this? 2, 10. As there is only one point, A1 is equal to 2, 10. So it will remain as 2, 10 only. Then C2. What is the value of A3? What is the value of A3? A3 is 8 plus 5. What is the value of A4? A4 is 5. So this is A part and this is B part. So how many values are there? 1, 2, 3, 4 and 5. What is this? 8. A3 of 8. A3 of 8 is this one and A3 of 4 is this one. So A3, first point of A3 is 8, second point of A3 is 4. Similarly A4, 5 and 8. 4 is 5 and 8. So similarly this is for all the A3, A4, A5, A6 and A7 divided by total 5 and 5. That is this, you divided by 5 you will get 6. This is also 6, 6 and C3. C3 is having only 2, A2 and A7. 2 and 5 that belongs to A2 and 1 and 2 belongs to A7. 2 plus 1 divided by 2. Why divided by 2? Because only 2 points. 5 plus 2 divided by 2, that is 1.5 and 3.5. These are the new clusters. Now I need to plot a graph. I need to plot the graph a 10 cross 10. So this is a 10 cross 10 point. So A1, what is the value of A1? What's the value of A1? What is the value of A1? 2, 10. So this is 2 and this is 10. So this is what your A1. So what is the value? So they take the second cluster. What is there in the second cluster? What is there in the second cluster? A3, A4, A5, A6 and 8. What is the value of A3? A3 is 8, 4. A3 is 8, 4. What is A6? 6, 4. What is A5? 7, 5. What is A4? 5, 8. What is A8? 4, 9. So out of this, which is a centroid? A4 is a centroid. So this is red mark. So A2 and A7. A7 is a seed point or it is a center point. So A2 value is 2, 5. A7 value is 1, 2. Now this is the case. Now when you increase the size of the cluster, now initially what we have taken, so he has asked you to okay, so then this is 10 by 10 space, that what we have formed out here. Okay, so this is the graph based approach, the graphical representation of the different clusters after applying the K-means clustering algorithm. Okay, so this is enough for this video lecture. So that is the end of the K-means clustering algorithm. In the next video lecture, we will go with the agglomerative hierarchical clustering. Okay, thank you.